Great, so now we're continuing on in chapter 3.5. So this is still the second lesson now on frequency tables and stem and leaf plots. So we looked at one frequency table where it used intervals. So we were looking at standing long jump results, and we found different intervals, for example, from 171 centimeters to 180 centimeters, 181 centimeters to 190 centimeters. So we had different intervals. As well, we can also choose frequency tables that don't work with intervals. So for example, sleep duration in the rounded number of hours and the frequency. It could be your favorite color or the favorite style of music and the frequency. Notice because you have total choice over the types of categories or the intervals or even the types of categories within the question, we call this the independent variable. You have more choice over the categories. What you don't have choice over is how the people will answer, and that's the frequency. And that's the frequency part, and that's what we call the dependent variable because it depends on the favorite or the different categories that you chose, favorite colors or the favorite style of music. For example, in this case, I could have split up pop and dance into two separate categories. I could have separated rock and alternative. I could have even included opera as a separate part of classical music as well. So because I choose those categories, my frequencies may be different. My independent variable will always be graphed in the x-axis, and my dependent variable will always be graphed on the y-axis. So then when we create frequency tables or frequency graphs using bar graphs, we're then able to plot out each different category and put the different frequencies for each one. Another special type of chart that we can use is called the stem and leaf plot. And I think we learned this early, you learned this in grade 4, but we can do this again. And what we can do is we look at these data points. So we look at these data points, same standing long jump results, but we're going to reorganize them into different intervals, but intervals based on their place values. What this means is let's determine the range first. So take this information down. You don't need to take the data points down. But the range of this information, as we saw, ranged from 172 to 230. Well, the stems will always be the numbers that are tens, are 100s, or the numbers that are not the last number. The last numbers are the ones that will be changing. These are called the leaves because there's the single digit that changes, and that's the last digit. The tens and the 100s digit, or even the thousands digit, will be the stems. So the stems are the tens or the 100s, and the leaves will be then the last digit. So if it happens to be in tenths, then the leaves will be the tenth number. So my stems will be put in here, and my leaves, or leaf, stem and leaf plot will be put in there. So as we remember, our range goes from 170 something, so our stem will be 170 something, 180 something, 190 something, 200s, 210s, 220s, and then 230s. The leaves then will be the numbers that are the single digits in the end. Now, if we had different data points, those leaves could be tenths or they could be hundredths, depending on the actual data points. So what we're going to do is we'll go along all of these numbers. What I want you to do is let's just take a look at the first one, 170s. Well, if we circle them, we have 172, 173. Let's just get rid of this one for now. And then I have 175. So I could just write those on the side, 173, 172, 175. But let's put them in numerical order. So for our leaves, we'll then put the smallest value first, which was the 2, then the 3, then the 5. I can then scratch them out because I put them on my chart. The 180s. So if I go through 180s, I see 187, so I'll put my 7 down. I have an 8. I have a 6, 186, another 186. I have 185 and 189. So those are my 6 ones. So I have 187, 188, 186, 186, 185, and 189. What I'll do is I'll put them in numerical order. So 185 goes first. Then I have two 186s in there. I have 187, 188, 189. So what I'd like you to do is pause the video and continue the rest of these data points based on the numbers that are there, what you see, and see if you can get the same answers we do. So if we continue along and we continue putting these numbers in order, I see that this ends up being 193, 93, 96, and 98. Then I have 0, 2, 2, 5, 5, 6, 7, and 8. I have 212, 12, 12, 214, 215, 215, 218, 220, 221, 221, 222, 223, 227, 228, and 229, and then 230. So if you notice the way I organized it, I organized it number one in numerical order, so that all the numbers are from the smallest to the largest, or from the least to the greatest. And then the second thing is I lined up the numbers just so that I can see which category or which interval has the most number of data points in it. So we're able to see the most frequent interval that's in there. Notice also the doubled or the tripled entries. I keep them as doubled or tripled in there as well. And what we could do is we can also check the number or the frequency. So I have a frequency of 3 plus 6 plus 4 plus 7 plus 7 plus 8 plus 1. And that gives a total of 36 data points. And I remember that there's a total of 36 at the beginning. So I know that that's the same. Let's just answer a couple of these questions. How is a stem and leaf plot like a frequency table? Well, in each case, we're divided into intervals. So we have intervals that we could use. And also, it's like it because I'm able to determine which intervals are more frequent or which intervals have more data points in it. So we can find the frequency. Now, what's not flexible, what's different, is that this in a stem and leaf plot, what's different is that the intervals are fixed. They have to go according to place values. That means that 170 somethings must be an interval. I cannot choose my intervals based on 171 to 180 like we did in the frequency table. In this case, the frequency table, the intervals are fixed. The benefit, though, of that is I'm able to determine the exact answers. Exact answers or data points are in the table. So that means in the frequency table, I saw that 170s only had 3 data points, but I couldn't tell what those are. In the stem and leaf plot, I am able to know what those 3 numbers are. So in this case, I'm able to find out what is the mode or the most frequent number, 212, out of all of this information. So number 2, what is the drawback of using a frequency table over a stem and leaf plot? Well, the drawback of using a frequency table, again, is that we lose the actual answers. So we lose the actual answers or data points. We lose the values. We don't know what the values are anymore. Once you put them in a frequency table, they just now move into counts of how many times it occurs. However, the benefit of using a frequency table is that we're able to choose the intervals ourselves. We could have chosen a variety of intervals. I could have chosen that 170s and 80s combined in a frequency table. Or I could use smaller intervals as well and have more frequent have my data spread out over different numbers of intervals. So we need to choose when you're looking at the questions in the textbook, which we'll be working on in class. When we're looking at those questions, you can really determine what frequencies you want to choose for each of those, or the intervals you want to choose, and you'll choose whether or not you want to